Hello guys, welcome back to my channel, and it's day 3 of covering electronics from very scratch level. So today we will learn something about that when you flick a switch and almost instantly an incandescent filament inside the bulb glows brightly in the dark. We tend to treat the power behind the light as a static number on the multimeter, a 1.5 volt level. However, the single value represents a physical event occurring at the scale of individual particles. Voltage is a measure of invisible, highly pressured repulsive force. It is a result of microscopic particles actively pushing away from one another. To understand this system's motion, we need to trace how a battery generates this pressure, how the force propagates at near the speed of light, and how we quantify the potential energy it leaves behind. We can begin by looking past the static labels on the schematic and observing the dynamic behavior of the electrical force itself. We start at the source. If we look inside a standard alkaline dry cell battery, we can examine its internal chemical architecture. Battery do not create electrons. The copper wiring already contains them. Instead, a battery functions as a pump, providing existing particles from one location to another location. Then, within the anode power, chemicals reactions strip electrons from their atoms, yielding a massive concentration of free electrons. The internal pump forces these particles together, piling them against the negative terminal. Because electron shares a negative charge, they naturally repel each other. Cramming trillions of them into a confined space creates a extreme overcrowding and an intense outward pressure. This is known as electromotive force or EMF. EMF is a manifestation of the artificially induced repulsive force at the terminal and waiting for an escape route into the circuit. Closing a switch provides that escape route, allowing the pent up repulsive pressure to disperse into the wire. If the electrons power the light, we have to account for the speed at very which they travel through the copper. The physical drift of the individual electron is remarkably slow, uh, roughly 0.002 millimeters per second. At this pace, it would take hours to reach the bulb. Instead, power transfer relies on the immediate repulsive shown to the next electron as shown here. This repulsive pulse, uh, the wave of pressure propagates down the line of electrons at near speed of light. The system transfer power through the light speed chain reaction of repulsive energy rather than the physical travel of individual particles. While this energy travels as a physical wave, we use mathematical formulas to quantify that invisible pressure. This is the formal definition of voltage. The difference in a potential energy per unit charge. U represent a potential energy, the capacity to do work, while Q represents the electric charge. Voltage is a relative measurement expressed as a delta V. It is defined that difference is a potential energy between 2 points rather than absolute property of single location. We see this when electrons move through a lamp filament. As they collide with atoms in the filament, they lose a portion of their potential energy, which is converted into heat and light. This energy loss results in a weaker repulsive pressure in the electrons exiting the components. Measuring a voltage drop in a way to calculate exactly how much physical potential energy was used to perform work within that component. If the voltage is always a relative difference between 2 points, analyzing a complex system requires a standardized measurement scale. We achieve this using a ground reference of 0 volt point. This is a mathematical anchor providing a baseline to measure every other point in the circuit against. Placing the ground reference at the negative terminal establishes a zero baseline. Defining the positive terminal as 1.5 volts, stacking batteries sums this pressure to 3 volts. This cumulative force is analogous to water columns. As the depth increases, water exerts higher pressure. The arbitrary nature of a ground point is most clear in a split supply configuration. By moving the 0 volt reference to the wire between the two batteries, the top terminal becomes positive 0.1 volts while the bottom terminal becomes negative 1.5 volts. A 0 volt reading does not indicate an absence of energy, it is simply the baseline we have chosen to map the measurement gradients of the system. We can now view the functioning flashlight circuit as a complete system. The operating circuit acts as a continuous pressure map. Repulsive electron pressure is the highest at the negative terminal and drops as energy is spent across the load. To maintain this flow, the chemical pump inside the battery must continuously resupply this pressure at the source. The closed switch allows the internal chemical concentration to release a wave of repulsive force that travels to the load at the near light speed. That static point voltage on a multimeter is measurable result of this relative pressure dynamics.